Ever get those ads online that are like eerily specific to something you were just looking at?
Or like when your navigation app seems to know about a traffic jam before you even hit it.
It's like, is my phone listening to me? Well, not quite. It's the magic of big data, this invisible force that shapes so much of our digital world. And today, we're taking a deep dive into how it all works.
Behind the scenes, it's fascinating.
Right. We've got an interview with a data expert who's tackled some seriously impressive challenges using tools like, Apache Spark and Hadoop. I mean, imagine having to process terabytes of data from sensors in real time to detect anomalies.
Yeah, there's this expert's everyday life.
Talk about pressure. And then on top of that, there's the whole challenge of storing all that data efficiently, making sure it's secure, making sure it's recoverable if something goes wrong.
Right. You got to balance speed, cost, and reliability. It's a lot.
So let's jump right in, starting with Apache Spark. Now, the expert we're featuring was tasked with processing, like I said, terabytes of sensor data to detect anomalies in real time. The catch: their initial Spark job was taking hours to complete.
Yeah, hours just won't cut it in a real-time system. I mean, what if something critical fails and you don't even know about it for hours because the data is still being processed?
Yikes. Talk about a disaster waiting to happen. So they had to find a way to optimize the Spark job, and one of the key techniques they used was something called salting.
Okay, I love this analogy. Imagine a giant bowl of candy, right? All the Skittles are clumped together. It's hard to get a good mix.
Exactly. So salting is like spreading those Skittles out evenly so you can grab a handful and get all the different flavors.
Exactly. In more technical terms, it's about dealing with data skew. That's when certain values in your data occur way more frequently than others. It creates these bottlenecks in your processing. So by salting, basically adding random suffixes to those values, you're distributing the data more evenly across your cluster.
And no more bottlenecks. So that one technique, just that, helped them reduce processing time significantly.
Real-time anomaly detection was suddenly possible.
Wow. So impressive. But they didn't stop there. They also dug deep into the Spark configurations, fine-tuning things like how much memory to allocate to different tasks.
It's kind of like, adjusting the carburetor in your car to get the best performance.
Perfect analogy. They also use this technique called broadcast joins. Super helpful when you have a smaller data set that needs to be combined with a larger one.
Right. Instead of moving all that data around, you replicate the smaller data set across all the nodes.
Saves a ton of time and resources.
Okay.
Clever.
But here's the thing. Choosing the right technique is key. Like, broadcast joins are great for smaller data sets, but if you try to use them with massive data sets, you could overload your system's memory.
Right. It's not a one-size-fits-all. You've got to know the trade-offs. And what really impressed me, they didn't just apply these techniques blindly. They went a step further.
Like, okay, instead of using a fixed number of salts, they created a dynamic system that calculated the optimal number based on how skewed the data actually was.
So smart.
And then they set up a feedback loop using tools like Spark UI and Prometheus. They were constantly monitoring performance and actually tweaking those configurations on the fly.
To get that peak efficiency, that's what separates a good data engineer from a great one.
For sure. It's not just about knowing the tools, it's about using them intelligently and, adapting your approach based on the data itself.
Totally. Okay, so we've tackled Spark. But now, what about Hadoop?
Hadoop.
How do you even begin to store and manage these massive data sets?
Right. Well, that's where Hadoop comes in. Famous for its distributed file system, HDFS, it spreads the data across multiple servers. But one of the biggest challenges with this kind of system is data locality.
Data locality, meaning?
You want to make sure that data is physically located as close as possible to where it's being processed.
Because I'm guessing moving large amounts of data across a network takes time, and time is precious when you're dealing with real-time insights.
Exactly. So our expert got strategic with HDFS policies, for example, rack awareness. So if you have multiple copies of your data for redundancy, they're stored on servers in different physical locations.
Kind of like having a backup generator for your data center. If one server goes down, you don't lose everything.
Precisely. That ensures data availability even if there are hardware failures. They also implemented tiered storage in Hadoop.
Tiered storage. Tell me more.
Imagine a library, right? You've got the high traffic area for popular books, and then you have the less frequented archive for rarely borrowed items. Tiered storage works similarly. Frequently accessed data is stored on faster, more expensive storage.
Makes sense.
While less frequently used data is moved to cheaper, slower options.
So it's all about optimizing for cost and performance.
You got it. And to manage all this, they used a whole suite of tools. Cloudera Manager, Ambari, HDFS quotas, and ACLs.
Sounds like a lot to juggle.
It is. But these tools give you the control and visibility you need to effectively manage a complex Hadoop cluster. Everything from monitoring resource usage to setting access permissions.
Okay, so we've covered a lot already, but there's one more technique I want to touch on before we move on. Erasure coding.
Ah, yes.
This is how they ensured efficient storage, even when dealing with, massive data sets.
It's a bit like a jigsaw puzzle. You break down your data into fragments and store those, along with extra parity pieces.
Parity pieces.
If you lose a few pieces of the puzzle, you can use the parity pieces to reconstruct the original image.
So you don't need to keep multiple identical copies of the entire data set. Saves a ton of space.
Exactly. But the question is, when do you use replication versus erasure coding?
Good question.
See, erasure coding is great for saving space, but it can be slower to recover data if a fragment is lost. So they made a strategic decision.
Yeah.
For data that needs to be accessed quickly, they stuck with replication, prioritizing speed. But for less critical data, they opted for erasure coding to prioritize storage efficiency.
Makes sense. It's all about using the right tool for the job. This is really making me rethink how I see the data behind everything I do online.
Just wait, we're just getting started.
Next, we'll dive into how they designed an entire data pipeline for real-time processing. We're talking the kind that powers those personalized recommendations you see online.
This is where it gets really interesting. We'll see how all of these concepts come together in a real-world system.
And we're back, still exploring the world of big data through the eyes of our expert, someone who's taken on those massive data sets and really complex systems. We saw how they optimize Spark jobs for real-time processing and how they manage these enormous Hadoop clusters. But now we're going to talk about building an entire data pipeline.
Oh, yeah.
This is the kind of pipeline that handles the real-time data that fuels those personalized recommendations you see online.
Right. Every click, every scroll, every purchase, it's all data. And it needs to be processed super quickly to deliver that seamless, personalized experience.
I know, it's mind-boggling how much data is being generated and processed behind the scenes to make that happen.
It is. And it can't be slow either. Users expect those instant results, no room for lag.
So how do they even approach this huge task?
Well, they started by embracing a microservices architecture. Think of it like building a house with individual modules, instead of trying to build the whole thing as one giant structure.
Okay, I'm following.
Each microservice is responsible for a specific function, and they all work together.
Seamlessly, right.
This gives you flexibility and scalability.
Yeah.
You can adjust each service independently based on what the system needs.
It's like having a team of specialized workers instead of one person trying to do everything.
Yeah.
So what were the key building blocks in this data pipeline? What did they use?
A really powerful trio of technologies. Kafka for queuing up those incoming messages, Spark Streaming for real-time processing, and Cassandra for storing the results.
Okay, break that down a bit for me.
Sure. Kafka is like a super efficient messaging system. Make sure data is delivered quickly and reliably, even if there are disruptions. Then Spark Streaming takes that data and processes it in real time, using techniques like salting and broadcast joins, the stuff we were talking about earlier.
Right.
And finally, Cassandra comes in. It's a highly scalable database, and it's durable, and that's where the results get stored.
So it's like a choreographed dance between these different technologies, each one playing a crucial role. But with so much data flowing through the system, how do you make sure it can actually handle the load?
Horizontal scaling. It's key. Instead of trying to make one server more powerful, you just add more servers to the mix, spreading out the workload, like adding more lanes to a highway to deal with rush hour.
Prevents those bottlenecks. Smart.
Right. But it's not just about adding more servers. They also use partitioning and replication.
Okay, remind me what those are again.
So partitioning means dividing the data into smaller chunks and distributing those chunks across multiple servers so they can be processed in parallel. Replication is like having backup copies of your data in case one server crashes.
So you're not just speeding things up, you're also protecting against data loss. Two birds, one stone.
Exactly. And they didn't stop there. They wanted to make the system even more reliable, so they built in fault tolerance mechanisms for both Kafka and Spark.
I like how they're thinking ahead here, planning for the what-ifs.
For sure. So Kafka, it uses replication and consumer groups to make sure messages are delivered even if a broker fails. Spark has checkpointing and recovery mechanisms that allow processing to continue from a previous state if there's a failure.
Like a safety net.
And then you've got Cassandra. built-in durability. Stuff like replication and consistency levels guarantee that the data is durable, even if some nodes go down.
So every step of the way they were thinking, how do we make this system as resilient as possible?
Absolutely. But they also needed speed, right? Low latency, so those recommendations are delivered in real time.
Of course, can't forget about speed.
So they got clever.
Mm.
Within their Spark streaming jobs, they minimize data shuffling. This cuts down on the back-and-forth communication between servers. They also used in-memory data structures, basically super fast scratch pads for rapid data access and processing.
It's like having a mental math whiz on the team.
They even tweaked Kafka settings to optimize for low latency, getting all the speed possible out of the system. Oh, and they also implemented monitoring, alerting, circuit breakers, and retry mechanisms to make it even more robust.
Circuit breakers, like actual electrical circuit breakers.
Kind of. There are safety switches in the system
Yeah.
that trip if things start to get overloaded. It's
Yeah.
really impressive how much thought went into every detail.
Totally. They were clearly thinking not only about the technical stuff, but also about the user experience.
Yeah, they were laser focused on creating a system that could deliver real-time insights, but without sacrificing reliability or scalability.
So we've seen them master Spark, tame Hadoop, and build this lightning-fast data pipeline that's also resilient. But now we need to talk about the human element.
It's a whole other challenge.
In the next part, we're going to look at how they navigated working in a matrix organization where you have data scientists, business analysts, product managers. They all rely on data to do their jobs.
So many moving parts, so
Yeah.
many different needs.
That's where communication and collaboration skills are so crucial, because building a great data system is one thing, but getting everyone on board and using it well, that's a whole other story. Welcome back to our deep dive. We've seen this data expert in action, optimizing Spark jobs, wrangling those huge Hadoop clusters, even building a real-time data pipeline.
It's pretty remarkable.
But now we're getting into a different kind of challenge, right? It's not just about the code anymore.
It's a human element.
Exactly. It's one thing to build a complex system, but getting everyone in an organization to use it effectively.
Okay, yeah, that's a whole other challenge.
Imagine you've got data scientists who are building these intricate models, business analysts who need the data to make big decisions, and then product managers who are trying to understand how all of this data impacts their features.
Everyone needs data, but they need it in different ways for different reasons. It can get messy fast.
So how did our expert bring order to all of that? Well, they started by creating a data architecture review board.
Such a smart move. It's like this central hub where everyone, data scientists, business analysts, product managers, can come together to talk about the data strategy.
Make sure everyone's on the same page from the get-go. Did they do anything else to keep everyone in the loop?
Oh, absolutely. They created a roadmap. It outlines the long-term vision for data within the organization. And they actually held workshops and presentations to keep everyone informed about the progress.
So important. Transparency and communication, especially when you're dealing with something as, I don't know, maybe intimidating as big data.
Right. It can feel really overwhelming.
So did they do anything to make sure everyone was, like, speaking the same language?
Yes. They developed a data dictionary. Think of it as like a glossary of terms, but for data. Defines all the key data concepts in a way everyone can understand. And they created detailed API documentation so that anyone who needed to actually access the data programmatically knew how to do it.
Like a user manual for the data itself?
Pretty much.
Yeah.
And to keep everything organized and transparent, they used tools like Confluence and Jira.
For tracking those requirements, decisions, and progress. So we've seen this expert code, architect, and even manage people. That's incredible. What are some key takeaways you think our listeners should really keep in mind?
Well, first of all, it's not just about the tools.
Yeah.
Spark, Hadoop, Kafka, they're all amazing technologies. But the real magic is understanding the problem and picking the right approach. And being adaptable, being willing to optimize along the way.
It's about problem solving.
Exactly. Second, it's about balance. Balancing those trade-offs like speed versus cost, efficiency versus reliability, right? These are things you always have to think about.
No easy answers. There's no one-size-fits-all solution.
Right. And finally, and this is so important, it's about people. Working with data at scale, it takes a collaborative mindset, really clear communication, and everyone has to be working towards the same goals. It's about bringing everyone along and making sure data is empowering, not scary.
So there you have it, our deep dive into the world of big data. We've covered everything from optimizing Spark jobs to the human side of managing all of this in a complex organization.
It's a lot.
But hopefully you, listening out there, have a new appreciation for the complexity and the sheer power of data.
I mean, think about how it's shaping your experiences every day. Personalized recommendations, traffic predictions, it's all around us.
And remember, behind all of that data are brilliant minds like the one we've been learning about today, working to make sense of it all and using it to make our lives better.
It's a fascinating field.
Yeah.
And it's always evolving. So keep exploring, keep learning, and keep asking questions. You never know, you might be the one leading the next big data revolution.